In these classes, we're going to want you to use a problem-solving board if you can. It looks like these take up a lot of space, and it seems like, oh, man, I don't want to do that. That's a lot of work. But really, it's actually the same amount of work. It's just organized differently. Eventually, you would do this all mentally, but for now, you don't know that. So I need you to draw a giant plus sign. And then you don't have to write exactly what's in these, but you want to write at least this. What do I need? What was given? You want to try some work. Maybe it works, maybe it doesn't work, but at least you tried something. And then after you get an answer, you need to check and see if that answer actually works, if it matches whatever is going on. Here we have Hudson and Knox are in a race. One person is running at 8.8 feet per second. That's a speed. So we can fill in 8.8. Knox got a 30-foot head start. Okay, well, there's a word that we missed before. Let's add that in. A head start means addition. Knox started 30 feet ahead of the other person, and his speed is 6.3 feet per second. How many seconds will it take until Hudson and Knox run the same number of feet? How many seconds? Okay, so this is going to be our variable because that's what we want to find. That's what we want our answer. We need seconds. And if I look back at what I thought, then Knox started 30 feet ahead. So somewhere I need to have a plus 30. That's going to be Knox. Knox has a plus 30. And then he also has a 6.3. And we'll add units to that in a little bit. We have this word, the same, which means we're going to have an equal sign between Hudson and Knox. And then on the other side of the equation, let's just put everything for Hudson. Hudson has 8.8 feet per second. And then let's add back in the units over here. I missed them before. .3 feet per second plus 30 equals 8.8 feet per second. We're trying to solve for how long it's going to take. So we need to add time, but not in the denominator. We're going to add time next to where it says feet per second. 6.3, and then I'm going to abbreviate. Feet per second. And then this is going to multiply by time. Let's just write the word time, because that's our variable. Plus 30 feet will be equal to Hudson's speed of 8.8 feet per second. And he is also going to be multiplying by time. If we wanted to solve this, the two numbers that are multiplying time would need to be brought to the same side, and then you would divide by that new coefficient. But we don't have to do that today. All we have to do today is write the equation, which we did. And now, does this make sense? Let's look at this with the picture. Knox is going to be purple. He has a 30-foot head start. And let's give him some arms. The other person, Mr. Orange, Hudson, he's back here. He's going to be running at 8.8 feet per second. That means he's going at a certain speed. Knox is going at 6.3 feet per second. So they're both going, but the difference is every second that passes, the orange guy is he's moving farther every second. If you rounded 8.8 up, it would round up close to 10, while the other one is going closer to 5. If you round very, very, very roughly, then Hudson's going almost twice as fast. So it's just going to take a certain amount of time for Hudson to catch up to Knox.